Welcome to Still Science Lab. Tonight, we embark on a journey into the most fundamental phenomenon of our existence, seeking to answer a question that has haunted the minds of geniuses for centuries and redefined our understanding of reality. What is light really made of? To ask this is to peer into the very mechanism of sight, for light is the medium through which the universe reveals itself to us. Every color we perceive, every shape we recognize, and every distant star we wonder at is brought to us by this singular messenger. Yet, despite its omnipresence, light remains one of the most elusive and paradoxical entities in the cosmos. It is the only thing we ever truly see, and yet, in its pure form, it is fundamentally invisible. We see the object's light illuminates the red of a rose, the blue of the sky, the cold grey of a mountain peak, but we never see the light itself as it travels through the void. It is a ghost that carries the world on its back, a messenger from the silence of space that speaks to us in the language of images. The mystery begins with the realization that light is a bridge between the observer and the observed. When you look at a tree, you are not touching the tree with your eyes. You are receiving a stream of information that has traveled from the sun, bounced off the leaves, and entered your pupils. But what is that information made of? If you were to freeze a single beam of light in mid-air and examine its internal structure, what would you find? Is it a collection of tiny, solid projectiles, microscopic bullets of reality that strike your retina like rain hitting a window pane? Or is it something more ethereal, a ripple in an invisible ocean, a vibration of the void itself that travels like a sound wave through the air? This is the central paradox that has divided the greatest thinkers of human history, and the answer to this question leads us away from the familiar world of solid matter and into a realm where the very definitions of thing and event begin to blur. For most of our history, we relied on our tactile intuition to explain the world. We assumed that if something can move from one place to another and have an effect, it must be a substance. This was the view of Isaac Newton, who imagined light as a stream of corpuscles, tiny, weightless particles that moved in straight lines. To Newton, light was a material object, a very refined form of matter that obeyed the same laws as a billiard ball or a planet. This made intuitive sense. Light travels in straight lines. It casts shadows with sharp edges. It reflects off mirrors just as a ball bounces off a wall. In this Newtonian world, the answer to what light is made of was simple. It is made of stuff. It is a series of discrete units, individual travelers that cross the vacuum to deliver their message. But even as Newton's particles dominated the scientific landscape, a more haunting possibility began to emerge. Other observers noticed that light didn't always behave like a collection of bullets. When light passes through a tiny slit or around a sharp corner, it doesn't just pile up in a straight line. It bleeds into the shadows. It bends. It behaves exactly like a wave on the surface of a pond. If you drop two stones into water, the ripples they create will eventually meet, crossing over one another to create complex patterns of interference. Light does the exact same thing. When two beams of light meet, they can reinforce each other to become brighter, or they can cancel each other out to create darkness. This behavior is the hallmark of a wave, not a particle. You cannot make two billiard balls hit each other and disappear, but you can make two waves meet and vanish into a flat surface. This suggests that light is not a material object at all, but a disturbance, a vibration that moves through a medium, just as sound moves through the air or a tremor moves through the earth. This creates an immediate and profound crisis of logic. If light is a wave, what is it waving in? Every wave we know of requires a medium. A wave in the ocean needs water, a sound wave needs air, a violin string needs the catgut or steel, but light travels through the absolute vacuum of outer space, a place where there is no air, no water, and no substance. This led scientists for centuries to hunt for a luminiferous ether, an invisible, all-pervading fluid that filled the entire universe, serving as the stage upon which light could ripple. They imagined that we were all swimming in a ghostly sea, and that light was simply the shivering of that sea. Yet, every experiment designed to detect this ether failed. The medium did not exist. Light, it seemed, was a wave that moved through nothingness. It was a ripple in a void. The mystery only deepens when we consider the invisibility of the messenger. Think of a beam of light crossing a perfectly clean, dark room. Unless there is dust in the air to catch the beam and scatter it toward your eyes, you cannot see the light itself. You only see the spot where it hits the wall. In the vacuum of deep space, this effect is even more dramatic. The universe is flooded with the light of 1 trillion suns, but space looks black. If you were standing in the void between Earth and the moon, the light from the sun would be passing all around you with incredible intensity, yet you would be surrounded by total darkness unless you looked directly at the sun or a planet. Light is the medium of visibility that hides itself in its own delivery. It is the messenger of the void because it requires nothing to exist, yet it creates everything we perceive as real. As we struggle to reconcile these two identities, the solid particle and the ethereal wave, we realize that light is forcing us to abandon our common-sense definitions of reality. To ask what light is really made of is to assume that the universe must fit into our pre-existing categories of particle or wave. But light refuses to be categorized. It is a chameleon that changes its identity based on how we choose to look at it. If we design an experiment to find particles, light obliges and shows us its graininess. If we design an experiment to find waves, light spreads out and shows us its ripples. This is not just a technical difficulty in measurement. It is a fundamental revelation about the nature of the cosmos. It suggests that at the deepest level, the stuff of the universe is not made of objects at all, but of something far more abstract and fluid. This brings us to a terrifying but beautiful conclusion. Light may not be made of anything in the way we understand matter. It might be the most basic unit of information in the universe, a fundamental limit that defines how things can interact. When we look at a photon, we aren't looking at a tiny piece of rock or a tiny bit of gas. We are looking at a quantum of action, a discrete event that carries energy across the void. Light is the software of the universe, the code that allows one part of the cosmos to know about another. It is the connective tissue of reality, the thread that weaves the past of a distant star into the present of your eye. In this introductory stage of our inquiry, we are left standing before a shimmering curtain. On one side, we have the world of Newton, a world of solid things and predictable paths. On the other side, we have the world of waves, a world of vibrations and interconnected fields. Light sits exactly in the middle, refusing to move. It is the ghost in the machine, the particle that isn't a thing, and the wave that has no ocean. It is the first clue that the universe we see with our eyes is only a tiny, filtered fraction of a much deeper and more mysterious reality. To understand what light is really made of, we must be prepared to let go of our reliance on substance and begin to think in terms of fields, energy, and pure mathematical relationships. The messenger has arrived from the void, and its message is that the world is not what it seems. The journey into the heart of light is ultimately a journey into the heart of ourselves. Because we are biological beings who evolved to survive in a world of solid objects, our brains are hardwired to see light as a tool, a mere utility for finding food or avoiding predators. We are not evolved to see the messenger. We are evolved to see the message. But tonight, we are stepping beyond our biological programming. We are asking the universe to show us its hardware. We are asking to see the light that makes the seeing possible. As we peel back the layers of this mystery, we find that light is the key to every door in physics, from the structure of the atom to the expansion of the universe, and from the flow of time to the very definition of energy. What is light really made of? Perhaps the answer is that light is the first thing that was made, and everything else we call reality is just the shadow it casts. To understand the modern war of quantum mechanics and the true nature of what light is made of, we must first go back to the original conflict that split the scientific world in two. This was the era of the giants, a 17th century world where the rules of the universe were being written by men who looked at a candle flame and saw two entirely different realities. On one side stood Isaac Newton, the English titan who had already mastered the heavens with his laws of motion and gravity. On the other stood Christian Huygens, a Dutch polymath of immense intuition and mathematical grace. Their disagreement was not a mere academic quibble. It was a fundamental rift in how we perceive the substance of existence. It was a great schism that asked whether the universe was made of discrete, countable things or continuous, flowing processes. This battle defined the boundaries of physics for over a century and established the two primary languages we still use to describe the cosmos: the language of the particle and the language of the wave. Isaac Newton's perspective was born from his obsession with mechanics. To him, the universe was a giant, orderly clockwork machine, and every part of it had to be a physical thing with mass, momentum, and a definite position. In his seminal work, Optics, he proposed that light was composed of corpuscles, vanishingly small, hard, and weightless particles emitted by luminous bodies. His reasoning was based on the most obvious behavior of light, its tendency to travel in straight lines. If you place an object in front of a light source, it casts a sharp, well-defined shadow. Newton argued that if light were a wave, it would bend around the edges of the object, just as sound waves from a person speaking behind a wall can still be heard by someone on the other side. Because light did not appear to leak into shadows, Newton concluded it must be a stream of projectiles flying through space like microscopic bullets fired from a sun-sized cannon. To Newton, light was a material object, a very refined form of matter that obeyed the same laws of inertia as a billiard ball or a planet. This corpuscular theory also offered a mechanical explanation for the mystery of color. When Newton used a prism to split white light into a rainbow, he believed he was not transforming the light, but revealing its internal ingredients. He proposed that white light was actually a mixture of different types of corpuscles, each corresponding to a different color. In his mind, red corpuscles might be larger or possess a different kind of momentum than violet ones. When these particles passed through the glass of a prism, the glass acted as a sorting machine, bending the different particles at different angles based on their size or speed. It was a purely materialistic view of beauty. Color was not a quality of the mind or a vibration of the air. It was a physical property of the stuff light was made of. This idea fit perfectly into the Enlightenment's desire for a world that could be measured, weighed, and categorized. However, across the North Sea in the Netherlands, Christian Huygens was looking at the same rainbow and seeing a very different story. Huygens was a master of clocks and vibrations, and he found Newton's particles to be an unnecessary and clumsy complication. He looked at the way ripples move across a pond and saw a perfect analogy for light. In his treatise on light, he argued that light was not stuff moving from point A to point B. Rather, light was a disturbance moving through a medium. He proposed that the entire universe was filled with an invisible, all-encompassing substance he called the luminiferous ether. This ether was composed of incredibly small, elastic particles packed so tightly that they were invisible and offered no resistance to the movement of the planets. When a candle was lit, it would strike these ether particles, causing a chain reaction of vibrations to spread out in all directions. Huygens' great contribution was what we now call Huygens' principle, a mathematical insight that remains a cornerstone of physics. He suggested that every point on a wavefront of light acts as a source for new, tiny spherical waves. As these millions of tiny waves move forward, they overlap and interfere with each other, creating a new wavefront. This explained the reflection and refraction of light with a mathematical elegance that Newton's particles struggled to match. While Newton had to invent strange and complicated fits of easy reflection and refraction, essentially suggesting that particles had internal moods that decided whether they would bounce or pass through glass, Huygens simply showed that reflection and refraction were the natural results of waves changing speed as they moved from one medium into another. For Huygens, the stuff of light was the ether, and the light itself was the movement of information through that ether. The biggest hurdle for Huygens, and the reason Newton's theory eventually won the first round of this war, was the problem of the shadow. If light is a wave, why doesn't it bend? Why can we hear around a corner but not see around one? Huygens argued that light waves are unimaginably small, so small that their bending around everyday objects is almost impossible to see with the naked eye. He was correct, but in the late 17th century, the technology did not exist to measure the tiny, microscopic diffraction of light. Without that proof, Huygens' argument sounded like a desperate excuse compared to Newton's clear, straight-line projectiles. In the court of scientific opinion, the bullet beat the ripple because the bullet was easier to visualize and fit more comfortably into the mechanical philosophy of the day. Physics, however, is often as much about the weight of authority as it is about the weight of evidence. Isaac Newton was the most powerful figure in the scientific world, serving as the president of the Royal Society and possessing a reputation that bordered on the divine. His success in explaining gravity and the orbits of the moon was so absolute that his peers were reluctant to challenge him on anything. If Newton said light was a particle, then for the majority of the scientific community, light was a particle. For over 100 years, the corpuscular theory reigned supreme, and Huygens' wave theory was relegated to a brilliant but incorrect minority view. Newton's prestige acted as a sort of intellectual gravity, pulling the entire field of optics into his orbit and stifling alternative ideas for generations. Yet, despite Newton's dominance, both theories contained hidden flaws that neither man could fully resolve. Newton's theory predicted that light should travel faster in water than in air to account for how it bends during refraction, a prediction that would eventually be proven wrong by the speed of light experiments in the 19th century. Huygens, on the other hand, could not explain the phenomenon of polarization, why light sometimes behaves differently depending on its orientation. They were both right about certain behaviors and wrong about others. But because they were trapped in the binary choice of particle versus wave, they could not see the third option. They were trying to describe a quantum reality using a classical vocabulary, and the messenger of the void was not yet ready to reveal its true face. The Great Schism was more than just a debate about the composition of a beam of light. It was a struggle over the soul of science. Newton's particles represented a universe of separate, disconnected objects governed by external forces, a universe of things. Huygens' waves represented a universe of connection, where everything is a ripple in a shared medium, a universe of processes. This philosophical tension is one we still feel today. Every time we struggle to understand how an electron can be a cloud of probability and a solid dot at the same time, we are returning to the battlefield where Newton and Huygens first drew their lines. We are still asking whether the world is made of solid building blocks or shifting patterns of energy. As the 18th century drew to a close, Newton's corpuscles were still firmly in control of the textbooks, but the pressure was building. The straight lines of the Newtonian world were beginning to show a certain softness at the edges. Small, nagging experiments were showing that light had fringes, delicate patterns of shadow and brightness that particles simply couldn't create. The schism was about to erupt again, and this time, the evidence for waves would become undeniable. The messenger of the void was preparing to show its second face, revealing that the stuff we thought we were looking at was actually a vibration of something far more mysterious than even Huygens could have imagined. The age of the particle was about to give way to the age of the wave, setting the stage for the greatest identity crisis in the history of human thought. The victory of the wave theory of light in the early 19th century brought with it a mystery that threatened to dismantle the very foundations of physics. While experiments had undeniably shown that light could interfere and bend like a ripple in a pond, scientists were left with a haunting question. What, exactly, was waving? In the mechanical world of the time, a wave was not a thing in itself. It was a motion of something else. A sound wave required air, a sea wave required water. If light was a wave, it required a medium, a substance that filled every corner of the universe, from the gaps between atoms to the vast reaches between galaxies. This hypothetical substance, the luminiferous ether, became the most sought-after phantom in science. It had to be strange beyond imagination, stiff enough to support the incredible speed of light, yet so ghostly and thin that planets could sail through it without slowing down. For decades, the greatest minds in the world tried to find this invisible ocean, only to realize that the answer to what light is made of was not a substance at all, but a ghostly ripple in a fabric they hadn't yet discovered. The breakthrough did not come from a study of light itself, but from the messy, sparking world of electricity and magnetism. In the mid-19th century, Michael Faraday, a man of profound intuitive genius who lacked formal mathematical training, began to see the world in a way no one else did. While others saw electricity and magnetism as forces that acted instantly across a distance, like invisible hands pulling on objects, Faraday saw fields. He imagined the space around a magnet or a battery as being filled with invisible lines of force, a literal spiderweb of influence that warped the space itself. Faraday's most radical hunch was that light might be related to these invisible webs. In a series of breathtaking experiments, he showed that a powerful magnetic field could rotate the orientation of a beam of light. This was the first smoking gun. It suggested that light was not a separate stuff, but was intimately connected to the electric and magnetic forces that governed the world of matter. However, Faraday's poetry of lines of force needed a mathematician to turn it into a universal law. That man was James Clerk Maxwell. Maxwell set out to do for electricity and magnetism what Newton had done for gravity. He wanted to find the master code. As he translated Faraday's insights into a set of 4 elegant mathematical relationships, Maxwell discovered something that would change human history forever. He found that electricity and magnetism were not 2 separate forces, but a single, unified phenomenon called electromagnetism. His equations revealed a beautiful, symmetrical relationship. A changing electric field creates a magnetic field, and a changing magnetic field creates an electric field. They were 2 sides of the same coin, locked in a perpetual embrace. As Maxwell played with these equations, he noticed a startling consequence. If you disturbed an electric field, it would trigger a magnetic field, which would in turn trigger a new electric field, and so on. This feedback loop would create a self-sustaining ripple, an electromagnetic wave that would race away from its source. When Maxwell calculated the speed at which this wave would travel through empty space, he reached a number that made his heart skip a beat: 300,000 kilometers per second. This was not just a random speed. It was the exact speed of light that had been measured by astronomers and physicists for centuries. In that moment of profound synthesis, the mystery of the ether began to evaporate. Maxwell realized that light was not a ripple in some invisible fluid. Light was a ripple in the electromagnetic field itself. It was an electromagnetic wave. This discovery redefined the stuff of the universe. For the first time, we understood that light is a self-propagating disturbance. It does not need a medium like water or air because it carries its own ocean with it. As the electric field part of the light wave oscillates, it creates the magnetic field part. As the magnetic field oscillates, it regenerates the electric field. They leapfrog over each other through the vacuum, a ghostly dance of energy that requires no physical substance to exist. This meant that the vacuum of space was not empty. It was a theater of invisible fields, and light was the music played upon them. We were no longer looking at light as a material object or a mechanical vibration, but as a fundamental expression of the universe's energy. Maxwell's unification was the first time in history that humans realized 2 completely different aspects of nature were actually the same thing. The spark of a carpet shock, the pull of a compass needle, and the glow of a sunset were all manifestations of the same electromagnetic field. This was the birth of field theory, a perspective that would eventually lead us to the doom of space-time and the holographic universe. It taught us that the stuff we see, the solid matter of our lives, is actually secondary to the invisible fields that fill the void. Light became the ultimate messenger because it was the purest form of these fields, traveling at the maximum speed allowed by the universe's logic. But if light is a wave in a field, it implies a terrifying level of abstraction. It means that when you look at a star, your eye is not catching a physical particle, but is resonating with a field that has been vibrating across millions of light years. The ghostly ripple suggested that the universe is not a collection of things, but a collection of relationships. The light from a distant galaxy is a message written in the language of electric and magnetic tension. This realization stripped away the last vestiges of the Newtonian clockwork universe. We were moving into a world where the primary reality was not matter, but the invisible, waving fabric of energy that connects every point in space to every other point. However, even as Maxwell's equations triumphed, they planted the seeds of a new crisis. His theory described light as a continuous, smooth wave, an infinite flow of energy. But as the 19th century closed, scientists began to find glitches in this smooth world. When they tried to calculate how much light a hot object should emit, the wave theory predicted an impossible result known as the ultraviolet catastrophe, suggesting that even a simple toaster should emit infinite amounts of high-energy radiation. The ghostly ripple was perfect for explaining how light traveled, but it failed to explain how light was born and how it died. The wave was too smooth for the rugged, grainy reality of atoms. Maxwell had shown us the how, but the what was still hiding a secret. The unification of electricity, magnetism, and light was the greatest achievement of 19th century physics. But it was not the end of the story. It was the bridge to the quantum world. We had discovered that light was an electromagnetic wave, but we were about to find out that this wave was made of packets, that the smooth ripple of the field was actually composed of individual, discrete events. The messenger of the void was about to reveal that it was not just a wave and not just a particle, but a quantum of reality that existed in a state of impossible duality. As we look back at Maxwell's breakthrough, we see the moment that light moved from being a mystery of optics to being the foundation of all modern technology. Every radio wave, every X-ray, every Wi-Fi signal, and every beam of sunlight is a testament to the ghostly ripple. We live in a world defined by the oscillation of Maxwell's fields. But even more importantly, we live in a world where we understand that the invisible is more real than the visible. The stuff of light is the tension of the universe itself, a vibration of the void that carries the energy of the stars into our lives. We have found that light is made of fields, but as we continue our search, we find that these fields are made of something even deeper, an informational code that governs the very possibility of existence. The unification achieved by Maxwell was a glimpse into the source code of the cosmos. It showed us that nature loves simplicity and that the most diverse phenomena can often be traced back to a single, elegant origin. Light, the messenger, had revealed that electricity and magnetism were its parents. But as we peer closer at the photon, we realize that the messenger is also a bridge to the weirdness of the quantum realm, where the smooth waves of Maxwell give way to the jagged, uncertain bits of the digital universe. The search for what light is really made of has led us from the solid corpuscles of Newton to the flowing ripples of Maxwell, and now it prepares to lead us into the heart of the quantum paradox, where light is everything and nothing all at once. By the end of the 19th century, the scientific world was resting on a bed of profound confidence. James Clerk Maxwell had seemingly delivered the final word on the nature of light, proving with mathematical elegance that it was an electromagnetic wave, a smooth, continuous ripple in the fields of the universe. The debate between Newton and Huygens appeared to have been settled once and for all in favor of the wave. Physicists believed they were merely tidying up the loose ends of a complete reality. However, a small, nagging experiment known as the photoelectric effect was about to act as the loose thread that would unravel the entire tapestry of classical physics. This experiment revealed a behavior of light that simply could not happen if light were only a wave. It was a crisis that required a revolutionary leap in thinking, and it was provided in 1905 by a young patent clerk named Albert Einstein. His discovery did not just fix a glitch in the data, it collapsed our comfortable understanding of a smooth universe and revealed that, at its most fundamental level, light is made of discrete, individual packets of energy. To understand the magnitude of this shift, we must first look at why the wave theory failed. The photoelectric effect occurs when you shine light on a piece of metal, causing electrons to be ejected from the surface. According to Maxwell's wave theory, light is a continuous stream of energy. If you wanted to knock more electrons off the metal or give them more speed, you should simply increase the intensity, the brightness of the light. In the wave model, a brighter light is like a more powerful ocean wave. It carries more energy, and when it slams into the shore of the metal, it should deliver a more forceful blow to the electrons. But when scientists actually performed the experiment, they encountered a reality that defied logic. They found that for many metals, red light, no matter how blindingly bright it was, could not knock a single electron loose. Yet, a faint, dim beam of violet light could eject electrons instantly. This was a total impossibility in a world of smooth waves. It was as if 1,000 massive, slow-moving ocean swells could not budge a pebble on the beach, but a tiny, sharp ripple could launch it into the air. The classical world had no explanation for why the color of the light mattered more than its total energy or brightness. This was the moment the smooth, continuous universe began to crack. Scientists realized that if light were truly a continuous wave, the energy would be spread out evenly across the wavefront, and it would take time for an electron to soak up enough energy to break free. But the electrons were jumping off the metal the very instant the light touched them. There was no soaking time. The energy was being delivered in a sudden, concentrated punch. Albert Einstein's genius was in realizing that the problem wasn't with the metal, but with our definition of light itself. Drawing on the work of Max Planck, who had suggested that energy might be emitted in chunks to solve a different problem, Einstein made a radical proposal that most of his peers initially thought was absurd. He suggested that light itself is not a continuous wave, but is composed of individual, finite quanta of energy. He imagined light as a hail of bullets rather than a steady stream of water. Each of these packets, which we now call photons, carries a specific amount of energy that is determined solely by its frequency or color. This changed everything. In Einstein's view, a beam of red light is made of a vast number of weak photons. Even if you have 1 billion of them, each individual photon lacks the necessary energy to knock an electron free from the metal's grip. It is like throwing 1 million ping-pong balls at a brick wall. No matter how many you throw, the wall will not fall. But violet light is made of strong photons. Even a single violet photon carries enough concentrated energy to kick an electron out of its orbit. This was the birth of the quantum. The stuff that light is made of was no longer a smooth, infinite field, but a collection of bits. Light was grainy. It was digital. This discovery was the true beginning of the quantum revolution. It forced us to accept a reality that is fundamentally chunky. Before Einstein, we believed that nature was an analog system where energy could be divided infinitely into smaller and smaller amounts. Einstein showed us that there is a bottom floor, a minimum unit of light that cannot be split. This is why we call it a quantum, from the Latin word for how much. The universe, at its core, is a series of discrete yes or no events. Either a photon has enough energy to move an electron, or it doesn't. There is no middle ground, no gradual buildup. The implications for what light is really made of are staggering. If light arrives in packets, then the messenger of the void is not just a vibration. It is a messenger that carries a specific, locked-in price of energy. This explains why certain types of light, like ultraviolet rays or X-rays, can damage our DNA while the visible light from a lamp cannot. It isn't about how much light there is, it's about the quality or energy of the individual photons. The stuff of light is a collection of energetic events, each one a tiny, self-contained universe of action. Einstein's discovery of the photon did not erase Maxwell's waves, but it created a profound tension that still haunts physics today. We were left with a wave-particle duality. Light behaves like a wave when it travels through space, spreading out and interfering with itself. But it behaves like a particle when it interacts with matter, striking like a solid object. This was the first time we realized that the true nature of reality might be something that the human mind cannot fully visualize. We can visualize a wave, and we can visualize a particle, but we cannot visualize something that is both and neither at the same time. Light was revealing itself to be a quantum object, a new category of existence that exists beyond our everyday experience. This shift in thinking also redefined the vacuum. If light is made of photons, then the void is not just a stage for fields to oscillate. It is a medium through which these packets of energy race at the speed of light. Every photon is a tiny, massless traveler that possesses momentum despite having no physical substance. When you feel the warmth of the sun on your skin, you are being pelted by trillions of these quantum messengers every second. They are striking the atoms of your body, transferring their discrete packets of energy, and causing your molecules to vibrate. We are living in a constant storm of light, a torrential rain of energy that we perceive as a steady, warm glow. Einstein won the Nobel Prize for this discovery, not for his theory of relativity, because the photoelectric effect was the first undeniable proof that the classical world was incomplete. It was the moment we realized that the stuff of the universe is not what it appears to be. The solid objects we touch and the smooth light we see are just the high-level renders of a much more chaotic and grainy reality happening underneath. By proving that light is made of quanta, Einstein opened the door to a universe where probability, uncertainty, and discrete bits of information are the true building blocks. As we look at the photon today, we see it as the fundamental unit of the electromagnetic force. It is the particle that allows electrons to talk to each other, the carrier of the very force that prevents you from falling through the floor. Light, once thought to be a mere byproduct of fire or the sun, was revealed to be the very currency of the physical world. It is the bit of the cosmic computer. We have moved from Newton's material bullets to Maxwell's ghostly ripples, and finally to Einstein's quanta of energy. We have found that light is made of packets, but as we continue to look closer, we find that these packets are even more mysterious than we imagined. They are not just little balls of energy. They are the keys to a reality where the observer and the observed are inextricably linked. The discovery of the quantum was the first step toward understanding that the universe is not made of stuff, but of information and events, and light is the primary way that information moves. To understand what light is really made of, we must eventually face the most haunting experiment in the history of science, a simple setup that shatters our logic and forces us to admit that reality is far stranger than we can imagine. This is the double slit experiment, a test so profound that the physicist Richard Feynman once remarked it contains the only mystery of quantum mechanics. We have followed the journey of light from Newton's solid bullets to Maxwell's ghostly ripples and Einstein's energetic packets. But here, at the heart of the quantum paradox, Light reveals that it is none of those things and all of them at once. The double slit experiment is the moment where light stops being a thing that exists in space and starts being a possibility that responds to our gaze. It is here that we realize the stuff of the universe is not made of matter, but of a terrifyingly fluid relationship between the observer and the observed. Imagine a simple barrier with two narrow, vertical slits carved into it. Behind this barrier is a sensitive screen that records where light strikes. In our everyday world, if we were to fire small, solid objects like tiny grains of sand at this barrier, the result would be predictable. Most of the sand would hit the barrier and bounce off, but the grains that pass through the slits would form two distinct vertical piles on the screen, directly behind the openings. This is how particles behave. They have a definite position, they move in straight lines, and they end up in one place or the other. However, if we were to replace the sand with water waves, the result would be entirely different. As a wave hits the two slits, it splits into two new wave fronts. These two ripples then spread out and overlap with each other, creating a complex pattern of interference. Where the peak of one ripple meets the peak of another, they reinforce to create a bigger wave. Where a peak meets a trough, they cancel each other out to create stillness. On the screen, this would appear as a series of many alternating bands of brightness and darkness. This is the hallmark of a wave. For a long time, this experiment was the ultimate proof for the wave theory of light. When light is shone through two slits, it creates that beautiful, striped interference pattern on the screen. But then came Einstein's discovery that light is made of discrete packets called photons. This created a crisis. If light is made of individual bullets of energy, how could it possibly create an interference pattern? To solve this, physicists decided to perform the experiment in the most delicate way possible. They fired photons at the barrier, one at a time. They imagined that by sending just one bullet every few seconds, they would finally see the particles act like particles. With only one photon in the air at any given moment, there would be no other light waves for it to interfere with. Surely, over time, two simple piles of hits would build up behind the slits, just like the sand. But the universe had a different plan. As the single photons struck the screen one by one, they appeared as individual, sharp dots just as Einstein predicted. But as the minutes passed and thousands of dots accumulated, a ghostly structure began to emerge. The dots were not forming two piles. They were organizing themselves into the striped interference pattern of a wave. This is the central nightmare of quantum mechanics. A single photon, traveling all by itself through the void, somehow knows about the existence of both slits. It acts as if it is a wave that passes through both slits simultaneously, interferes with itself on the other side, and then decides where to land on the screen based on that interference. How can a single, discrete packet of energy be in two places at once? How can a particle interfere with its own ghost? This is where we must let go of the idea that light is a thing like a grain of sand. At this level, light is made of a wave of probability. Before the photon hits the screen, it does not exist as a solid point in space. Instead, it exists as a cloud of possibilities, a mathematical wave function that describes all the places it could be. It is not moving through one slit or the other. It is exploring every possible path simultaneously. It is in a state of superposition, existing in a ghostly limbo where it is both here and there, and everywhere in between. Light, in its fundamental state, is not made of matter, but of potential. It is a ripple in the logic of the universe that only solidifies into a particle at the moment of impact. But the mystery takes an even darker turn when we try to catch the photon in the act. Scientists wondered if they could trick the universe by placing a tiny detector at the slits to see exactly which hole the photon actually passes through. They wanted to see the truth behind the veil, but the moment they turned the detector on, the universe changed the rules. As soon as we have information about which path the photon takes as soon as we watch it pass through a specific slit, the interference pattern on the screen vanishes. The photons stop acting like waves and start acting like simple, solid bullets. They form two plain piles behind the slits. The very act of observing the light collapses the wave of probability into a single, definite reality. This observer effect is perhaps the most unsettling discovery in all of science. It suggests that light does not have a fixed identity. It is a wave when we don't look and a particle when we do. The stuff that light is made of is seemingly sensitive to the presence of information. It is as if the universe refuses to show us its internal machinery. As soon as we peer into the gears, the machinery hides, and we are presented with a simplified, particle version of reality. This has led some of the greatest minds in physics to suggest that we cannot talk about reality as something that exists independently of our measurements. Light is a conversation between the void and the observer. It is a bit of information that only becomes an it of matter when a question is asked. This means that the messenger of the void is not just carrying news from a distant star. The messenger is shaped by the very person receiving the message. If light is made of these waves of probability, then the entire universe might be a vast, interconnected web of possibilities that only crystallizes into the solid world we see because we are here to witness it. The double slit experiment tells us that the boundary between the mind and the world is not as clear as we thought. Light is the bridge where the abstract logic of mathematics meets the concrete experience of sight. As we struggle to visualize a single photon going through two slits at once, we must realize that our brains are simply not designed to understand the true nature of light. We evolved to see a world of solid objects and either-or choices. Our intuition tells us that a thing must be either here or there. But light tells us that here and there are just labels we use to organize our limited interface. In the quantum realm, light is a wavicle, an entity that exists in a state of infinite potential until it is forced to choose a side. This is why light is so hard to define. We are trying to use the language of the macro world to describe the poetry of the micro world. The double slit paradox is the ultimate proof that the solid world of matter is a secondary projection. Underneath the colors and the shapes of our lives lies a restless, shifting sea of quantum information. Light is the primary expression of this information. It is the stuff that proves that the universe is not a machine, but a process. It is a reminder that even in the darkest void, there is a hidden dance of possibilities happening just out of sight. We are living in a world of ghosts, and light is the only ghost that has the kindness to show itself to us. As we move forward in our search for what light is really made of, we carry this paradox with us. We have seen that light is a particle, a wave, and a probability. But the story does not end with this confusion. By accepting that light is a quantum object, we open the door to even more radical ideas. If light can be in two places at once, And if it responds to our observation, then what does that say about the nature of time and the vacuum of space? We have found that the stuff of light is a massless, bodiless entity that defies our logic. Now, we must look closer at this bodiless particle, the photon, to see how it can possess power and momentum while having no weight at all. We are moving from the paradox of the wave to the mystery of the massless, and in doing so, we are moving closer to the realization that we ourselves are part of the light we are trying to understand. To truly grasp what light is really made of, we must confront a concept that challenges the very definition of existence as we know it. In our daily lives, we are surrounded by things that have bodies. A stone, a drop of water, a grain of dust, all of these possess mass, take up space, and have a tangible presence. We have spent our history thinking of particles as tiny versions of these things, like microscopic marbles. But when we look at the photon, the fundamental unit of light, we find a particle that possesses no body at all. It is a thing that is empty of all the qualities we usually associate with matter. It has no mass, no physical size, and no electric charge. Yet, in one of the most beautiful contradictions in physics, this ghostly, weightless entity possesses the power to push against the world. It carries momentum, delivers force, and serves as the ultimate engine of cosmic change. The photon is the universe's way of proving that something does not need to be substantial to be real. The most striking feature of the photon is its absolute lack of mass. In the classical world, everything has rest mass, a certain amount of stuff that remains even when the object is sitting still. But a photon is never sitting still. It is born in motion, and from the very first nanosecond of its existence, it is traveling at the maximum speed allowed by the laws of causality. To understand why a photon must be massless, we have to look at the relationship between mass, energy, and speed. If a photon had even the smallest, most infinitesimal amount of mass, it would require an infinite amount of energy to reach the speed of light. Because it moves at that universal limit, it is mathematically required to be weightless. It is a particle made of pure, unadulterated energy, unfettered by the heaviness that binds the rest of the material world. When we ask what light is made of, the answer is a substance that is defined by its lack of substance. It is an excitation of the vacuum that carries no baggage. This masslessness leads to a profound existential difference between the light that illuminates us and the atoms that compose us. You and everything you touch are made of fermions particles like electrons and quarks that have mass and obey the rules of exclusion, meaning they cannot occupy the same space at the same time. This is why you cannot walk through a wall. Your atoms bump into the atoms of the wall. But photons are bosons. Because they have no physical body or volume, they do not take up space in the traditional sense. You can overlap an infinite number of photons in the exact same spot, and they will simply pass through each other like ghosts in the night. They do not collide. They do not crowd each other out. This is why a laser beam can be packed with an unimaginable amount of energy without the beam ever getting thicker. Light is a crowd of phantoms that can coexist in a single point, a testament to the fact that the stuff of light is not matter, but information and tension. However, the ghost has a punch. One of the most counterintuitive discoveries in physics is that while a photon has no mass, it still possesses momentum. In our everyday experience, momentum is the product of mass and velocity. A heavy truck has more momentum than a bicycle. But since the photon's mass is zero, our classical intuition tells us its momentum should also be zero. The universe, however, operates on a deeper logic. The momentum of a photon is derived not from its weight, but from its vibrancy or its frequency. A photon of blue light, vibrating faster, carries more of a kick than a photon of red light. This isn't just a theoretical curiosity. It is a physical reality that we can measure. We call this radiation pressure. If you stand in the sunlight, the photons striking your skin are actually pushing you. The force is so tiny that you cannot feel it, equivalent to the weight of a single postage stamp spread over a large area, knowing it is there. In the vacuum of space, where there is no air to offer resistance, this light pressure becomes a powerful tool. We can see the physical evidence of the photon's punch in the tails of comets, which always point away from the sun because the flood of solar photons is literally blowing the comet's dust into space. Engineers are even designing solar sails, massive, reflective sheets that use the momentum of sunlight to propel spacecraft across the solar system without the need for fuel. It is a staggering thought. A weightless particle with no body and no size can move a ship through the stars simply by striking it. This tells us that the stuff of light is a form of active energy. It is a transaction of force that bypasses the need for a physical body. When a photon hits an atom, it doesn't crash into it like a ball. It transfers a discrete packet of momentum, a quantum of push, that can launch an electron into a higher orbit or set a molecule into a frantic vibration. Furthermore, the photon carries no electric charge. It is perfectly neutral. This might seem like a minor detail, but it is the reason the universe is visible to us. If photons were charged, they would constantly be interacting with each other, bending and crashing as they crossed paths. The sky would be a chaotic, opaque mess of electromagnetic collisions. Instead, because they are neutral, photons can travel across billions of light years of space, passing through magnetic fields and electric storms without being deflected. They are the perfect, impartial messengers. They bring us the news from the edge of the observable universe exactly as it was sent, undistorted by the journey. This neutrality is part of what makes light the ultimate observer. It can move through the world without being tangled in it until the moment it finally strikes a surface and delivers its energy. By examining the photon as a particle without a body, we are forced to move away from a materialistic view of the world. We often think of the universe as a collection of bricks, matter, held together by glue forces. Light is that glue. It is the carrier of the electromagnetic force. When two magnets pull toward each other, or when an electron stays in orbit around a nucleus, they are talking to each other by exchanging virtual photons. In this sense, light is the very language of the physical world. It is the mechanism that allows one part of reality to affect another. If we removed light and the force it carries, the solid world of atoms would instantly fall apart. We are held together by the very thing we cannot grasp, a bodiless, weightless vibration that serves as the foundation for all structure. This brings us to a deep philosophical realization. If the most fundamental and influential particle in the universe has no mass and no size, then substance is not the most important quality of reality. Perhaps the universe is not made of stuff at all, but of actions and events. A photon is an event. It is a moment where energy is released and then captured. It is a quantum of action. We see the world as a collection of objects, but physics tells us it is a collection of transactions. Light is the primary currency of those transactions. It is the purest form of being because it exists at the very limit of what can be considered a thing. It is the boundary where mathematics becomes physics and where information becomes energy. As we stand in the light of a lamp or the glow of the sun, we are being touched by trillions of these bodiless messengers every second. They are striking us with a force we cannot feel, bringing us information from sources we can never visit, and keeping our very atoms from drifting away into the void. The photon is the messenger of the void because it is a piece of the void that has been given a purpose. It is the ghost that runs the machine. We have found that light is made of these massless, bodiless quanta, but the mystery is far from solved. Because these particles have no mass, they obey a different set of rules regarding time and space. They are the only entities that can touch the absolute limit of the cosmos, and in doing so, they experience the universe in a way that we, with our heavy bodies and slow movements, can barely imagine. To understand the photon, we must now look at the strange way it experiences time, or rather, the way it escapes it entirely. To understand what light is really made of, we must look beyond its physical properties of energy and momentum and examine its relationship with the most fundamental dimension of our experience, time. We have explored the photon as a bodiless particle, a massless messenger that carries the force of the universe. But because it lacks mass, the photon is granted a privilege that no other piece of matter can ever possess. It is the only entity that can travel at the absolute cosmic speed limit, a velocity so profound that it bends the very fabric of reality. In our everyday world, we think of light as a very fast traveler, crossing rooms in an instant and reaching us from the sun in about 8 minutes. But from the perspective of the light itself, the journey is entirely different. For a photon, there is no journey, there is no distance, there is no waiting. Because light travels at the speed limit of causality, time literally stops. The photon exists in a state of eternal now, a frozen clock that bridges the beginning and the end of the universe in a single, timeless flash. This realization emerges from the heart of Einstein's theory of relativity, which teaches us that space and time are not separate, fixed stages, but are woven together into a single, flexible fabric called space-time. One of the most startling consequences of this union is that the faster you move through space, the slower you move through time. This is not a psychological trick or a failure of our clocks. It is a fundamental law of the cosmos. If you were to board a spacecraft and travel at 99% of the speed of light, you would find that while years might pass for the people you left behind on Earth, only days or weeks would pass for you. Your heartbeat would slow, your cells would age more slowly, and every tick of your watch would stretch out relative to the rest of the world. You are trading your movement through time for movement through space. As you push closer and closer to that ultimate speed, the stretching of time, what physicists call time dilation, becomes more extreme. If you could reach 99.999% of the speed of light, you could cross the entire galaxy in what feels like a few months. While back on Earth, 100,000 years would have vanished into history. But for anything made of matter, anything with even the tiniest amount of mass, that final, absolute limit remains forever out of reach. As you approach the speed of light, your energy increases, but so does the effort required to go even faster, making it impossible for a physical body to ever truly touch the limit. Only the photon, the bodiless particle, can exist at that boundary. And at that boundary, the trade is complete. The photon moves through space at the maximum possible velocity, and as a result, its movement through time drops to zero. For a beam of light, time does not exist. This is perhaps the most difficult concept for the human mind to grasp, because our entire existence is defined by the flow of seconds, minutes, and years. We perceive light from a distant star as having traveled for millions of years across a vast, cold vacuum to reach our eyes. We see the star as it was in the ancient past, perhaps long before humans even walked the earth. But if you could ask the photon about its journey, it would tell you that it was born at the surface of that star and arrived at your retina at the exact same moment. For the photon, there was no million-year flight. There was no empty space to cross. In its frame of reference, its birth and its death are simultaneous events. It is a frozen clock, an entity that experiences the entire history of its existence in a single, indivisible instant. This means that the stuff of light is fundamentally timeless. While we see the universe as a sequence of events, a beginning, a middle, and an end, light sees the universe as a single, static snapshot. Every photon that reaches us from the edge of the observable universe, having traveled for over 13 billion years from the dawn of time, feels as though it were created just now. It has not aged a single picosecond since the Big Bang. In this sense, light is a bridge that connects the disparate parts of the universe, not just across space, but across the ages. It is the only thing that remains fresh and unchanged by the passage of eons. When you look up at the night sky, you are not just looking at old light. You are touching a part of the universe that is still living in the moment of its creation. This timelessness forces us to reconsider what light is made of. If light experiences no time, then it also experiences no distance. In the mathematics of relativity, as time dilates to infinity, space contracts to zero. From the photon's perspective, the universe has no depth. The point where it was emitted and the point where it is absorbed are touching. This suggests that the messenger of the void is actually an entity that collapses the void entirely. It is a thread that stitches the fabric of space-time together, making the distant near and the ancient present. We see a vast gap between us and the sun, but the light sees a universe where we and the sun are in direct, immediate contact. This is why light is the fundamental constant of the universe. It is the 0 point where the separations of our three-dimensional world disappear. If light is timeless, then it exists in a realm that is pre-space-time. It is a manifestation of a deeper reality where the distinctions between before and after do not apply. We have long thought of light as something that moves through space and through time, like a car driving down a highway. But relativity tells us that light is the highway. It defines the geometry of the world. The speed of light is not just a speed. It is the refresh rate of reality. It is the speed of causality, the maximum rate at which one event can influence another. If light were any faster, or if it were instantaneous, the very concepts of past and future would crumble into a chaotic soup. Light is the clock that keeps the universe's story in order for us, even as it remains outside of that story itself. This frozen clock nature of light has profound implications for our understanding of existence. If the fundamental unit of our reality is a timeless photon, then perhaps time itself is an emergent property, a kind of illusion created by the way our massive, slow-moving bodies interact with the light. We are like creatures moving through a thick syrup, experiencing the drag of time because we have mass and cannot reach the light. But the light is free. It is the only part of the universe that is truly awake to the timeless nature of the real. It is a reminder that there is a level of existence where nothing is ever lost, where the first light of the first star is still burning with the same intensity as the lamp on your desk. As we stand in the glow of the world, we are being touched by the eternal. Every photon hitting your eye is a messenger that has traveled zero distance in zero time, bringing with it the energy of a source that might be long dead in our time, but is still alive in the light's now. We are looking at a universe that is both ancient and brand new at the same time. Depending on whether you look through human eyes or through the logic of the photon, light is made of this impossible duality. It is the motion that defines speed, yet it is the stillness that defines the eternal. By exploring the frozen clock of the photon, we realize that light is not just a thing made of energy. It is a perspective on reality. It is the vantage point of the universe itself, looking at its own creation without the distortion of the passage of time. We have found that light is massless, bodiless, and timeless. It is the ultimate expression of the void's potential. But if light is timeless and connects all points in space, then how does it interact with the matter that is bound by time? How does this eternal messenger communicate with the grains of dust and the cells of our bodies? To answer that, we must look at the dance of interaction, the way light acts as the glue of the world, mediating the forces that allow us to exist at all. We are beginning to see that light is not just something we look at. It is the reason there is anything to look at in the first place. The discovery that light is a timeless, massless messenger brings us to a crossroads where we must ask a startling question. If light is so ghostly and ethereal, why does the world feel so solid? We have spent our lives believing that the stuff of the universe is matter, the heavy, tangible atoms that make up our bodies, our homes, and the earth beneath our feet. We think of light as something that merely reveals these objects, a secondary actor that illuminates the stage. But as we dive into the profound world of quantum electrodynamics, or QED, we find that the roles are reversed. The solidity of the world is an illusion, a macroscopic mask worn by a frantic, invisible dance of light. Every physical thing you have ever touched, from the softness of a petal to the cold hardness of steel, is held together by the constant, relentless exchange of photons. Light is not just what we see. Light is the glue of reality. It is the fundamental force that prevents you from falling through the floor and keeps your very atoms from drifting apart into the void. This revolutionary understanding was pioneered by Richard Feynman and his colleagues, who transformed our view of the subatomic world into a theater of interaction. Before QED, we imagined that forces like electricity and magnetism were just fields that somehow existed in space. But Feynman realized that a force is not just a vague influence, it is a conversation. He proposed that when two charged particles, such as two electrons, push each other away, they are not doing so through some magical action at a distance. Instead, they are tossing a messenger back and forth. That messenger is a photon. In the world of QED, light is the force carrier for the electromagnetic interaction. Every time an electron shifts its position or feels the pull of a nucleus, it is because it has absorbed or emitted a quantum of light. This means that the stuff of light is actually the currency of all physical relationships. To understand the sheer scale of this dance, consider the act of sitting in a chair. To your senses, Your body is resting on a solid wooden or plastic surface. But on the level of the atom, there is no such thing as touching. The electrons in the atoms of your skin and the electrons in the atoms of the chair are all negatively charged. As you bring them close together, they repel each other with incredible intensity. They do not hit each other like two marbles. Instead, they begin to frantically exchange photons. They are shouting at each other through the vacuum, using the electromagnetic force to say, "Stay back." The sensation of solidity you feel is simply the collective resistance of trillions upon trillions of these light-mediated exchanges happening every second. You have never truly touched another person or a single object in your life. You have only ever felt the repulsive force of light pushing back against you. This realization shifts the very foundation of what we believe we are made of. We are accustomed to thinking of ourselves as biological machines made of meat and bone. But meat and bone are made of molecules, and molecules are held together by the electromagnetic force. The chemical bonds that link your DNA, the signals that fire across your neurons, and the structure of the proteins in your muscles are all governed by the exchange of photons between electrons. Light is the architect of the biological world. Without this constant dance of interaction, the electrons would fly away from the nuclei, the atoms would dissolve, and the structured universe would vanish into a disorganized soup of subatomic particles. We are, in a very literal sense, held together by light. Richard Feynman's genius was to simplify this unimaginable complexity into what we now call Feynman diagrams. Though they look like simple doodles, they represent the fundamental logic of the universe. In these diagrams, particles move through time and space, and where they meet, they exchange a photon. This simple act, the emission and absorption of a light particle, is the source of almost everything we experience in the physical world. It explains why magnets pull, why electricity flows through a wire, and why the sun generates heat. It is a single, elegant mechanism that governs the vast majority of our reality. The messenger of the void is not just bringing news from the stars, it is the mediator of every event on Earth. However, the photons involved in this glue are often different from the ones we see with our eyes. Many of the photons that hold your atoms together are virtual photons. They are transient, ghostly versions of light that pop into existence just long enough to carry a message from one electron to another before vanishing back into the vacuum. They are the hidden light of the universe, working behind the scenes to maintain the integrity of matter. This suggests that the vacuum itself is a roiling sea of potential light, a reservoir of force that is constantly being tapped by the particles of matter to define their positions and relationships. The stuff of light is not just the bright beams of the sun, it is the invisible network of tension that gives the universe its shape. This perspective brings a new depth to the question of what light is really made of. If light is the carrier of the electromagnetic force, then it is the primary language of the cosmos. Every interaction between matter is a sentence written in photons. When you look at a mirror, you are seeing a massive, coordinated exchange where photons from a light source strike the electrons in the silver of the mirror, causing those electrons to re-emit new photons back at you. When you feel the heat of a fire, you are absorbing infrared photons that set the molecules of your skin into a frantic dance. Everything is a transaction. Everything is a movement of light. QED is often called the most successful theory in the history of science. because its predictions have been tested to an incredible degree of accuracy, like measuring the distance from New York to Los Angeles to within the thickness of a single human hair. This precision tells us that the dance of interaction is not just a metaphor, it is the absolute truth of our physical existence. We live in a world where the distinction between matter and light is becoming increasingly blurred. Matter is the hardware, but light is the software that tells the hardware what to do. It is the code that allows the universe to be something more than just a pile of cold, static dust. As we ponder this, the philosophical implications begin to surface. If we are held together by light, and if all our sensations are mediated by light, then light is the primary interface between our consciousness and the world. We do not experience matter directly. We only experience the light messages that matter sends us. This returns us to the idea that the universe is a process of perception. The dance of interaction is a constant universal conversation, and we are both the participants and the observers. The light that illuminates the stars is the same stuff that allows your heart to beat and your brain to think. In the quiet of the lab, as we consider the floor beneath us and the air around us, we must realize that there is no empty space. The void is filled with the frantic, invisible buzzing of photons, crossing paths, striking electrons, and weaving the tapestry of the solid world. We are walking through a blizzard of light every moment of our lives, and it is this blizzard that gives us the illusion of a stable, material home. The messenger of the void is the ultimate protector, the force that ensures that when we reach out to touch the world. By understanding QED, we have found that light is the fundamental interaction of our lives. It is the massless, timeless glue of the cosmos. But if light is the refresh rate of this interaction, and if it defines the very boundaries of how we touch and see, we must ask, why does it move at the specific speed it does? What is the significance of that ultimate limit, the speed of light? As we move closer to the final understanding of light's nature, we must examine the speed of causality, the cosmic limit that keeps the story of the universe from happening all at once. We have seen the dance. Now we must understand the tempo of the music. 299,792,458 meters per second. This is the most important number in the universe. It is a value so precise and so absolute that it defines the very geometry of our existence. We call it the speed of light, but this name is actually a historical accident, a remnant of a time when we thought light was a special substance moving through a static world. In reality, this number does not belong to light at all. It belongs to the universe itself. It is the speed of causality, the maximum rate at which one event can influence another, the fundamental refresh rate of the cosmos, and the ultimate logic gate that prevents the entire story of the universe from happening all at once. To ask what light is really made of is to eventually realize that light is simply the first entity we discovered that is light enough to travel at the speed of reality. In our everyday lives, we experience the world as a place of instant reactions. When you flip a light switch, the room is illuminated immediately. When you call a friend across the city, their voice reaches you without a perceptible delay. Because of this, our brains have evolved to perceive the world as simultaneous. We believe that now is the same everywhere, that now on Earth is the same as now on Mars, or now in a distant galaxy. But the speed of causality tells us that this is a profound illusion. There is no universal now. The universe is not a single, synchronized clock. It is a vast, disconnected web of events that are limited by a cosmic bitrate. This bitrate is the speed of light. It is the speed at which news travels through the fabric of space-time. To understand why this limit exists, we must imagine what the universe would look like if the speed of causality were infinite. If information could travel instantaneously, the concepts of space and time would effectively vanish. Cause and effect would occur at the exact same moment. In such a universe, every star in the cosmos would be visible to us exactly as it is in this microsecond. And every event in the history of the universe would be entangled in a chaotic, immediate soup of interaction. There would be no distance, because distance is only meaningful if it takes time to cross it. By imposing a finite speed limit, the universe creates the separation required for a story to unfold. It allows for a sequence of events, a past, a present, and a future. The speed of light is the wall that protects the present from the future and keeps the past in its proper place. This is why we call it the speed of causality. Causality is the simple rule that the cause of an event must always precede the effect. If you throw a stone at a window, the throw must happen before the glass breaks. This sounds like common sense, but it is actually a hardwired law of physics maintained by the speed of light. If any signal or any piece of information could travel faster than this limit, it would be possible, through the mathematics of relativity, to create a scenario where the effect happens before the cause. You could see the window break before the stone was even thrown. The universe would lose its logical consistency. It would become a place where the laws of reason no longer apply. The speed of light is the logic limit that ensures the universe remains a coherent, orderly system. When we ask why the number is exactly 299,792,458 meters per second, we are asking about the fundamental tension of the vacuum. Just as the speed of sound is determined by the density and elasticity of the air it travels through, the speed of causality is determined by the stiffness of the electromagnetic fields that fill the void. It is a constant of nature, like the strength of gravity or the charge of an electron. If this number were different, the entire structure of the universe would change. A slower speed of light would mean that atoms would have to be much larger and move more slowly to maintain their stability. A faster speed would change the way energy is distributed across the stars. This specific number is the tuning of our reality. It is the tempo of the cosmic music. But why is light the thing that travels at this speed? The answer lies back in our discovery that the photon is a particle without a body. Because the photon has zero mass, it is not weighed down by the fabric of space-time. Anything with mass, even an electron or a tiny grain of dust, experiences a kind of friction with the Higgs field, requiring energy to move and making it impossible to ever reach the ultimate speed limit. But the photon, being massless, has no choice. It is born at the speed of causality and must remain at that speed for its entire existence. It is like a car with no brakes and an engine that only has one setting: maximum. Light is the default speed of the vacuum. It is the purest expression of the universe's movement because it carries no baggage. This realization transforms our understanding of the vacuum itself. We tend to think of the vacuum as nothingness, an empty stage where things happen. But the existence of a finite speed of causality proves that the vacuum is a something. It has properties. It has a latency. If you were to play a high-end video game, the The frame rate is limited by the hardware of the computer. The universe is much the same. Space-time is the hardware, and the speed of light is the maximum processing speed. When a star explodes in the Andromeda galaxy, the data of that explosion begins to ripple toward us. But the hardware of the universe can only move that data at a specific rate. It takes 2.5 million years for that information to reach our eyes. We are not just looking at a distant object, we are waiting for the universe to render that event for us. This creates a beautiful and haunting reality where we are always living in the past. When you look at the person sitting across from you, you are seeing them as they were a few nanoseconds ago. When you look at the moon, you see it as it was over a second ago. When you look at the sun, you see it as it was 8 minutes ago. The speed of causality ensures that every observer in the universe lives in their own private bubble of time, seeing a version of the world that is slightly out of date. We are all historians of the immediate past, piecing together a reality that is being delivered to us at a finite speed. This limit also defines the boundaries of what we can ever know. There is a concept in physics called the light cone, the region of space and time that can be reached by a signal traveling at the speed of light. Anything outside of your light cone is, for all intents and purposes, not part of your reality. There are galaxies so far away that their light will never reach us because the expansion of the universe is pushing them away faster than light can travel. They are forever beyond our causal horizon. They exist, but they can never affect us, and we can never affect them. The speed of light is the boundary of our observable universe, the edge of the map beyond which there is only silence. By looking at light as the speed of causality, we find the final piece of the puzzle regarding its composition. Light is made of the very timing of the universe. It is the physical manifestation of the fact that the universe has a speed limit. It is the messenger that informs us of the rules of the game. When we see light, we are seeing the update of the world. We are seeing the result of the universe's logic being transmitted across the void. The photon is not just a particle, it is a bit of causality. It is the fundamental unit of influence. As we ponder this, the messenger of the void takes on its most majestic form. It is the protector of logic, the weaver of time, and the constant that holds the entire chaotic expansion of the Big Bang into a readable, orderly sequence. Light is what allows there to be a here and a there, a now and a then. We have followed the light from the material bullets of Newton to the ghostly ripples of Maxwell, through the discrete packets of Einstein and the probability waves of the quantum realm, until we have reached the very foundation of space-time. We have found that light is made of energy, fields, and probability, but most of all, it is made of the universe's will to be understood in a specific sequence. It is the speed of reality itself. We are now ready to bring all these threads together. We have explored the physics, the history, and the logic of light. We have seen how it holds our atoms together and how it freezes time at the edge of the cosmos. In the final stage of our journey, we must look at the big picture. If we are made of atoms held together by light, and if we see the world through the limit of causality, what does that tell us about our own nature? We are about to find that we are not just observers of the light, we are a part of it. The fabric of reality is not a cold, dead thing. It is a shimmering tapestry of energy, and we are the points where the light finally becomes aware of itself. We have reached the end of our journey into the heart of the most familiar mystery in the universe. We began by asking a simple question: what is light really made of? And we have found ourselves wandering through a landscape of particles, waves, fields, and timeless paradoxes. We have seen light act as a bullet, a ripple, a discrete packet of energy, and a ghostly mediator of force. But as we stand at this final threshold, we must confront the most profound realization of all. Light is not just something that exists in the universe, illuminating the objects we touch and the stars we wonder at. Light is the very fabric of reality itself. We are not merely passive observers of a bright world. We are, in the most literal sense of physics, made of the same fundamental essence. The messenger of the void is not just bringing us news of the cosmos. It is the substance from which the cosmos is woven. To understand this, we must return to the deepest insight of modern physics, the unbreakable marriage between energy and matter. For centuries, we believed that the world was divided into two categories: the stuff that has weight and occupies space, and the energy that moves it. But we now know that this distinction is an illusion born of our limited human perspective. Mass is simply a form of highly concentrated, trapped energy. If you were to peer into the heart of an atom, past the electrons and the nucleus, you would find that there is no solid core. There is only a frantic, vibrating field of energy held in a state of intense tension. If you were to unravel the matter that makes up your body, it would release a staggering amount of pure energy, the same energy that powers the stars and defines the nature of light. In this sense, every atom in your skin, every drop of blood in your veins, and every breath you take is a form of frozen light. We are energy that has learned how to slow down, how to take shape, and how to linger in the void. This transforms the story of light from a study of optics into a study of existence. When we look at a beam of light, we are looking at the universe's purest, most unrestricted state. Light is energy that has no mass, and therefore no weight to hold it back from the ultimate speed limit of causality. Matter, on the other hand, is energy that has acquired the burden of mass, slowing it down and binding it into the structures we call atoms. But the underlying stuff is the same. The photon is the soul of the cosmos because it represents the fundamental activity of the universe before it is constrained by the heaviness of being. We are the shadows cast by that primal light, the complex patterns formed when energy decides to stay in one place. This realization brings us to the beautiful concept of the universe as a self-perceiving entity. For billions of years after the Big Bang, the universe was a sea of light and cooling matter, a vast theater of energy with no one to watch the play. But through the long, slow process of evolution, the universe began to organize itself into increasingly complex forms. Eventually, it created the eye and the brain. At that moment, something miraculous happened. The light that had been traveling through the void for eons finally had a destination. Through us, the universe developed a way to see itself. When you look at the stars, it is the universe looking at its own history. When you look at a flower, it is the energy of the cosmos recognizing its own beauty. Light is the bridge that allows this conversation to happen. It is the thread that connects the distant, ancient fire of a star to the conscious mind of a human being. Without light, the universe would be a collection of disconnected events happening in total silence. With light, it becomes a unified reality, a single story being told and heard at the same time. The photon, therefore, is more than just a particle. It is a quantum of awareness. It is the smallest possible unit of information that can move from one place to another. Every time a photon is absorbed by your eye, a connection is made. The void is momentarily bridged. We often feel small and insignificant when we contemplate the vastness of space, but we forget that we are the points where the light of that vastness finally achieves meaning. Without the observer, the wave of probability that light represents would never collapse into a single, beautiful image. We are the partners of the light, the entities that turn the abstract math of the quantum world into the lived experience of color, warmth, and sight. This perspective allows us to see the beauty of the photon in a new way. It is a massless, bodiless, timeless traveler that defies every common sense rule of our lives. It is the only thing in the universe that can touch the beginning and the end of time in a single instant. It is the force that holds our atoms together and the messenger that tells us we are not alone in the dark. In the stillness of the night, when we look up at the silver glow of the moon or the faint twinkle of a galaxy millions of light years away, we are witnessing the soul of the cosmos in motion. We are seeing the primary language of existence. We have found that light is made of many things. It is a vibration of electric and magnetic fields. It is a discrete packet of energy. It is a ripple of probability, and it is the speed of causality. But at the deepest level, light is the will of the universe to manifest. It is the first let there be that brought the void into being. It is the underlying radiance that remains when all the temporary structures of matter eventually fade away. Physicists tell us that in the incredibly distant future, long after the last stars have burned out and the last black holes have evaporated, the universe will once again be a sea of nothing but thin, cold light. We began in light, and we will end in light. The material world we inhabit is just a brief, beautiful interruption in the eternal life of the photon. Tonight, as you look around your room, try to see the light not just as a utility that helps you find your way, but as the very essence of the reality you inhabit. Every surface you see is a conversation between photons and electrons. Every shadow is a place where the messenger has been momentarily blocked. The warmth you feel is the energy of a distant star being transferred into your very being. We are living in a shimmering, interconnected web of light, and every moment of our lives is a testament to the fact that the void is not empty. It is full of potential, full of message, and full of life. The search for what light is really made of has led us from the solid world of our ancestors into a realm of pure abstraction and wonder. We have learned that the more we try to grasp light, the more it slips through our fingers, revealing itself to be a ghost that runs the machine of the world. But in that elusiveness, we find the truth. The most important things in the universe are often the things we cannot hold. The things that are massless, timeless, and invisible are the very things that make existence possible. Light is the ultimate example of this truth. It is the invisible messenger that reveals the world, the timeless traveler that connects the ages, and the frozen energy that makes up our very hearts. As we close this chapter of our investigation at Still Science Lab, let us carry with us a sense of gratitude for the photon. It is a tiny, humble entity, yet it carries the weight of the entire universe on its weightless back. It is the soul of the cosmos, the spark of consciousness, and the bridge between the nothingness and the everything. We are made of the stars, but more importantly, we are made of the light that allows the stars to be seen. In every beam of sun and every flicker of a candle, the universe is whispering its secret to us, reminding us that we are part of a grand, luminous dance that has no beginning and no end. The light is still there, even when we close our eyes. It is the background hum of the vacuum, the silent vibration of the fields, and the eternal now of the quantum world. We have looked into the glare and found not just physics, but a reflection of ourselves. We are the light of the world, and the world is the light in us. Good night, and see you in next video.